I'm Anna Mitchell and I'm a research scientist, and I'm interested in what happens in our brains when we're trying to learn new information and make decisions. The way that I do this is I work with monkeys doing behavioural and cognitive neuroscience. And we use monkeys because we think, just like humans, that they're very good at learning new information quickly and weighing up different decisions in order to be able to make the optimal choice. What we do is we get the monkeys out into transport boxes and we wheel them down to touchscreen computers, and we get them to reach out and make responses to the touchscreens. And they do this for a reward palette. It's a banana flavoured palette that they enjoy. And then we get them to look at the touchscreen and present 3 different objects, clip art objects, on the touchscreen. And these clip art objects are very different. They're very colourful, and they're typical cartoon images of different objects. We associate one of those 3 objects with an 8 out of 10 probability of receiving reward, another object with a 2 out of 10 probability of receiving reward, and that third object is not associated with a reward at all. The monkey sees those same 3 images within a testing session, and then across days they see new objects, and they have to learn within the session and then across days quickly which ones are the ones that are giving them the reward. They work through about 300 trials per day, and we get the data from that. Then when we know that they've trained up well in doing the task, then we want to intervene in their brain and change a little part of it in order to be able to see how that part of the brain is influencing their ability to learn new information or make these decisions quickly. So what we do is we do neurosurgery with the monkeys, and we inject a very small amount precisely into the particular brain structures that we're interested in. One particular area of the brain that I'm interested in is the centre of the brain called the medial dorsal thalamus. And the monkeys, after the neurosurgery, recover quickly. We keep them in a quietened room and supervise them throughout and make sure that they're well and getting the medicine that they need. And then within about 24 hours, we've got them back in with the group in order to be able to integrate them back with their cage mates. We typically leave them for about another 2 weeks to be able to make sure that they're fully recovered before we get them back in to do the testing and the performance of the task again. And again, they're seeing 3 objects associated with different reward probabilities, but they're seeing new ones again, and then seeing new ones within the session and across days of testing. And again, we're interested in seeing how this part of the brain affects their ability to be able to learn new information quickly and then to make decisions quickly by changing within the session which particular object they're interested in. The medial dorsal thalamus is particularly critical for this. If you don't have your medial dorsal thalamus, then what we find is that the monkeys keep choosing all of the 3 objects. They keep sampling all 3 of them. They can't integrate that information to know which one is giving them the 8 out of 10 probability of receiving reward. Why we are doing this is that we are interested in obviously understanding how the brain works. So these studies are helping us advance our fundamental knowledge about how the brain is involved in learning new information and making optimal decisions in a changing environment. This type of information can help us then for understanding what might be going wrong in the brain of people who can't make optimal decisions or learn new information. And potentially it could also help all of us to be able to make more optimal decisions or to improve our ability to learn new information.